This video is going to be about a source for 12 volts DC to power your equipment. And what it entails is using one of these old server power supplies. A friend of mine gave me an old server, and in it had two of these big supplies here. They're 870 watts, output 12 volts at 71 amps. So that's quite a bit of current. It has on the back you can see the fan. It's got a special connector here so you could drop these into the server and lock them in. Now this is a switch mode power supply, so you may have a problem with noise if you use it on your ham radio equipment. So it would probably be a good idea to have some kind of a hash filter on the output. Another thing you might want to consider, I think very important, is put some kind of a crowbar on the output. Maybe set for like 15 volts. Something with a big SCR on it that would fire if the voltage gets above 15 volts. It would short it out. You don't want to connect this up to your very expensive ham radio transceiver without some kind of protection on it. It probably has internal protection, but being able to supply 71 amps, that's like a welder, so you'd have to consider that. So I'm going to open this up and look inside and see what we got. I know I'm going to have to modify this connector here some way, but then I'll put a load on this thing and see just exactly what it puts out. Things seem like they're well made, and being made for servers, I'm sure it's probably a higher quality supply than you'd find in your home computer. So I'm going to open it up and we'll check out and see what we got inside this thing. After removing 8 screws, this thing comes apart fairly easy. This comes off, and then this hinges up, exposing the innards here. Real compact here. There's a real high density circuitry in here. I think before I go too far though, I'm going to power this on and measure and see what my output pins are. I don't have any documentation with this, of course. This is a model N870P-S0, if I can see it here. It's got some indicators here. LED states green, AC present, yellow fault. Alternating green and yellow is a power supply mismatch of some type. So anyway, I guess I'll move forward. I've applied 120 AC to the unit and it's not firing up. So I'm assuming there's probably some type of a signal it requires from the mainframe here to allow the power supply to start up. And I have a feeling you could probably hot swap these, looking at the way it's constructed here. Not sure about that, but obviously we're going to have to figure out how to power this thing without it being connected into a server system here. So that will be one of my next things I need to do. I have the unit jumpered here to get it to run. This fan speed is way too high. I'm going to have to find a way to slow that down, but it's kind of a dirty signal. I'm getting about 110 millivolts of ripple at a frequency of about 139K. That wouldn't be suitable, I don't think, for running any sensitive equipment. But running through the appropriate filter should smooth a lot of that noise out. A hash filter and maybe some more filter in here. But between that and the high-speed fan, I'm going to have to try to control that fan speed. That's really loud. Sounds like a jet taking off. This is one of the nice things about having an isolated scope on one of these meters here. You're not tied to the power line grounds, so you're safe to take measurements like this. I'm not drawing any current right now. The output is 12.2. Oh boy, that thing is, the camera's not going to allow me to use this digital voltmeter. I'm going to hook up a regular voltmeter so you can actually read it. Good old Simpson 260. Never let you down. 12 volts. I bet they don't have a 12 volt scale on here. Oh well. It's on the 50 volt scale. I don't have a load on this, so I don't know. I should probably put a heavy load on it and see what happens. Now this is interesting. I just put a seal beam incandescent lamp on. This is a couple amps. The voltage is still 12.1. It dropped 1/10 of a volt, but the fan speed is slowed way down. So with no load, the fan was running full bore, and it's slowing down even more. So evidently, without a load, the fan is running full speed. Interesting. Now it's barely perceptible. This is not too bad. I always thought I'd have to put some kind of a fan control in here, but as long as you're running a load on it, I don't think it really matters. Yeah, see, the fan is slowing down to almost nothing. Still 12.1 volts. And I believe there's some pots in here. I may be able to run the voltage up just a little bit. Okay, I'm going to remove the load here. See what happens to the fan. It's accelerating. It's interesting. Okay, I'll reconnect the load. Okay, the load's reconnected. And the fan is decelerating. That's strange. Add a load and the fan slows down. That's just exactly the opposite of what I thought would happen. Still 12.1 volts. See if it slows down as slow as it did before. There must be a thermistor or something in there that is controlling that speed. Maybe it's a PWM signal with a fan. I don't know. Why it slows down with load, I have no idea. Be interesting to put a 50 amp load on it. I don't have anything down. I have to go down to the building and pull up some big heavy resistors if I want to do that. Let's see if we wanted a 50 amp load at 12 volts, let's see. That's about 0.24 ohms. Some of these test leads here, got to be careful with some of these jumper cables here. In fact, if you get these things, you want to pull the insulator off and re-solder the connectors. They're usually, when you buy them, these little clip leads, they're usually crimped on, and with time they develop corrosion and they get dodgy on you. It can be really confusing, get you running in circles. I usually just cut them off and solder the ends on. There we are, we're slowing back down again. Weird. I was able to download this off the internet for this particular power supply. This has the pinouts on it. Now 2 amps I'm pulling on that incandescent bulb here at 12.1 volts. Well, this is kind of interesting. Watch what happens when I stop the fan. It shuts down. That's kind of neat. I'll pull the power plug out. I'll plug it back in. Power's back up. Kind of neat. So if the fan stops, it automatically shuts down. But these were expensive to make. Yeah, looking at the innards here. This has got some this is a very well made power supply. I know I would not want to fix it. What a nightmare. This thing is so densely packed, and this is the motherboard to that server here. Quite large. Right here are the power connectors where 2 of these power supplies would plug in. So I need to salvage these 2 sockets. The nice thing about that is these power supplies will plug directly in. They plug directly into these sockets. So if I can remove these from the main board here without damaging them, I should be able to repurpose them and use them where I can plug these supplies in directly. I think that's a better option than to carve up this the output of this power supply here. That way I can keep the power supplies. I got 2 of them. I can keep those as a unit. Now here's an unexpected but pleasant surprise. I knew I had to unsolder these connectors here with a myriad of connectors on the bottom of the board, and I thought, how am I going to unsolder it? This is a multi-layer board. It's going to be a real pain. It uses that crummy no-lead solder that takes a lot of temperature, but I looked at the bottom of the solder pads and they didn't look quite right to me. It didn't look like they were soldered. Well, I did a little prying and found out they were just pressed into these holes. These holes, they're plated through holes, and they make the connections here. So both of these came out without having to unsolder. What a pleasant surprise. It was just the contact to the board there. So you got to remove one of these things. Put your soldering iron away and take out a prier and something to pry it off there. So the nice thing about that is there's my mating connector for these power supplies right there without any desoldering. The only thing is I will have to let's see, 1, 2, 3 will go to positive and 3 will go to negative, so I'll have to tie all of these pins to a negative and all of them to a positive, whichever. I'll have to check which is which. And then my jumpers, to get it to run, will go on this side. So then you just plug it in and away you go. So anyway, that was a pleasant surprise. Well, here are the main output cables here. What I did was I split the conductors into 3 sections and I soldered them. There's 3 to the positive and 3 to the negative. These are number 8 gauge, I believe it is. Anyway, the way it works is these connectors will just slide in like this. Slide in like this. And these are the outputs. And then these outputs here will go, I can put in a, I think if I build a crowbar circuit, I'll build it all separate over here. So the power supply will feed a filter and crowbar, and then I'll have some output terminals, some studs that I can connect to the device I want to power. So anyway, number 8, that should be big enough for anything I'm going to power on these things. And of course I've got a jumper 3 of the pins on this connector on the right, and I'll do that here. I'll just jumper those on the, let's see, here's the input end, and then they come out the back, so I can just jumper across these pins here so I can force the unit to power on. Here's the 3 pins that need to be jumpered. This will be grounding the 2 pins here. So with those 3 grounded together, the unit should power up when it's applied 120 volts on the input. Here's the completed connector, and I have a seal beam, about 2 amps, connected to the output. Got my Simpson and a little panel meter, so I'm going to apply power, see what happens. Well, we got 12 volts, and the fan slowed right down, which is what I wanted. Okay, well, I'll let this run a while and then go on to the next step. Here's an example of how you can use this power supply, which is rated at 71 amps, 12 volts. You can run the output into a bus similar to this. It's a fuse bank, and you can connect your positive and negative lead to the input of this, and then feed each of your rigs off of this, and then you can put in fuses to match whatever you need. Okay, this one has 11 outputs here, and you can mount a little panel meter on it if you would like. And this one is, well, since this thing is multiplexed, it's acting kind of goofy here. But on the camera, with a naked eye, this is a solid 12.0 volts. And I believe there's a way to raise the voltage in these a little bit. There are other YouTubes and people that have used these power supplies, and you might want to check those out. I had a few of them with pinouts that I couldn't get mine to work. I had to ground the 3 pins. Here's one guy that had some information, and this really helped because it numbered the pins and it gave the function. But on his, he had a 10K resistor, these 2 shorted. This pin would be A6, and according to this chart, A6 you ground to turn the fan on. This pin here, this one would be C6, supply kill, it says ground to turn on. Now then he shows a 10K resistor up to this pin. For me to get this to work, I didn't connect a 10K resistor here. I connected these 2 pins to this one here. This would be B2, I believe. So I grounded B2 to A6 and C6, and by grounding those 3 together, the unit came on and supplying power. So anyway, on my unit, that's what I had to do. So experiment around with it to see what you need to do. Another thing I would do is between the output here and any loads, I would connect a crowbar just in case. Now this is short circuit protected. I did test it. I shorted it and it shut the unit off, but what I'm worried more about is that there's a malfunction in this unit that would supply a higher voltage to your devices. So if you connect a crowbar across these two terminals here, that would protect your rigs here. But this should supply pretty much any amateur radio transceiver at 71 amps. That's more than ample. So I'm going to end this one so it doesn't get too long. And it's a nice way to repurpose these power supplies. I got two of them here. I'm going to experiment with this one. I'm going to see about raising the voltage. I'd like to get it up to maybe 13.2 volts, something like that. That would be fine. So that's it for this one. I hope you enjoyed it. Thanks for watching, and I'll see you in the next one. Bye for now.